we had just done was we took a binomial, we multiplied it together, and we made a trinomial. Now when we factor, we take the trinomial and we split it apart into the two binomials that it would have made, or that would have multiplied together to make it, rather. Two ways to do this. There's kind of the standard way to do it, which is like a table with factors and sums. And then method 2 is my method, big giant X. It's like the game show method. Okay, so what happens, hold on one second. When I take two binomials, actually let me make that nice. And I multiply them together. Okay. This is going to give me x squared plus x minus 30. Just take my word for it. If you look, 6 and negative 5 multiply to make the negative 30. And 6 plus negative 5 adds together to make this 1. That's what's happening. So what we're looking for are the two numbers that would go here that would make this happen. So we're going backwards. So when I look at the 7x squared, or sorry, x squared plus 7x plus 12, I'm looking for factors of 12 that are going to give me that 7. So when you make a factor in sum table and you have no coefficient on the first term, all you need to look at is the 12. So I'm looking for factors of 12 that will give me a sum of 7. Okay, and sometimes that's really quick. You might have already thought of them. Sometimes that takes a little longer. I'm going to not go with the ones that are the correct answer just to show you how to go through the whole process. So I go, okay, 12. 1 times 12 is 12. But if I do 1 times 12, I get 13, right? 1 plus 12 is 13. Okay. And I go, okay, well, 2 and 6 multiply to make 12. But then 2 plus 6 is 8. So I would say, okay, well, 3 and 4. Oh, 7. Yay. I got there. Okay, so you would just try a bunch of them until you got the right ones. And then once you have the correct ones, that's what goes in your parentheses. Now the big giant X eliminates all of that writing. We make a big giant X. And we do a plus, and we do a multiply. And plus is the number in the middle, multiply is the number at the end. And I say, okay, I need two numbers to go on either side of the X, that when I add them I get 7, and when I multiply them I get 12. Same process as the table, just in a different format because sometimes the way different people's brains work, one way or the other is more accessible.
Should it be x plus 4, not 7?
Yes, you're right, thank you. Wrote 4, 7, wrote 7. With this one, it's more like a game. Like I said, it's more like the game show version. Instead of writing all the factors out and adding them, you have to kind of think about it. And so you start thinking about factors of 12. You just like run through them in your head and add them together. So I go, okay, 1 and 12, 13, no. 2 and 6, 8, no. 3 and 4, awesome. So I put those here. 3 plus 4, 7. 3 times 4, 12. And the numbers on the side of the X are what go in the parentheses. It's the exact same process, it's just presented visually in a different way. And sometimes one way or the other will resonate more with someone, make more sense. table or big giant X for the first one? Table. Table, okay. Oops. So I'm gonna do factors of 8. And I want their sum, and I want it to equal 6. Well, factors of 8, 1 and 8, 2 and 4.
Is this
Oh.
like plus 6x?
Yeah, plus 6x. Sorry, it's a little small, isn't it?
Squared plus 6x plus 8.
Yeah, x squared plus 6x plus 8. So if I look at 8, I've got 1 and 8 and 2 and 4. If I add these together, I get 9. If I add these together, I get 6. We have a winner. X plus 2, x plus 4. Okay, now so far everything's been positive.
Okay, got it.
Got it?
Mhm.
Okay. So far everything's been positive. Here I have a positive middle term and a negative end term. Now, negative 35. And I want the sum to be 2. To multiply and get a negative number, what do I have to have? Yeah, one positive, one negative, right? So I have to, when I do this, I have to take this into account. And so if I do 1 and 35, I can either have a negative 1 or a negative 35. Okay. If I have a negative 1, I'm going to get a 34. If I have a negative 35, I would get a negative 34. Does that make sense? Okay. Neither one of which is a 2. The other factors of 35 are 7 and 5. If I make the 7 negative, I would get a negative 2. So I want that 5 to be negative. So then I get my positive. Does that make sense? Yeah? So this is going to be x plus 7, x minus 5. Now, if we were doing the big giant X thing, same kind of idea. I need to find factors of negative 35 that are going to add together to give me a positive 2. And so you say, okay, well, 7 and 5 go together and have a difference of 2, and I want the 2 to be positive, so that makes the 7 positive and the 5 negative. But as you, either way works, you just have to kind of manipulate the signs on this.
Negative for the down part.
Yeah, I put, well, if the 35 was positive, it would be positive 34. If the 35 was negative, it would be negative 34. So, it depends. Does that make sense? Excuse me. Okay, so we've had all positive, we have a positive and a negative. Oops. Where's somebody still writing? Okay, so I've had 2 positives, a positive, then a negative, and now I have 2 negatives. Okay. I'm looking for factors of 16 that are going to give me a negative 6. Well, what multiplies to make 16? And which one has to be negative?
8.
So, x minus 8, x plus 2. And the order of these don't matter. You could do x plus 2, x minus 8. Don't feel like one of them has to go in front. That doesn't matter. Because multiplication is commutative, which means the order doesn't matter. Why don't you guys, so the first way is, like I said, it's sort of like a big kind of convoluted factor and sum table. So I have factors of 3, factors of 28. And I need a sum of negative 20. Okay?
Well, facts would be, couldn't that just be 1 and 3?
Yeah, that's just going to be 1 and 3. Okay, 28 though gives me a couple different options. I'm going to start with 2 and 14. Now, somehow in here, I need a negative. Now this is positive and this is positive, but my sum is negative, which means that when I multiply two numbers together, I'm going to get a positive, but when I add, I'm going to get a negative. Excuse me. That means my two numbers have to be negative. When you're dealing with this situation, it's always this last term that we go with the negative numbers, not the first factors, not the coefficient on the x squared. So this is going to be a negative 2 and a negative 14. Because when I add, I'll get a negative number, but when I subtract, I'll get a positive. Now I have to try combinations. If I do 1 times negative 2 and 3 times negative 14, I'm going to get negative 2 minus 42, which is going to give me negative 44. That's not going to work. But I can't discount the 2 and the 14 because I can change the things that get multiplied together because I have 2 sets. So I come in here and then I try 1 times negative, 1 times negative 14 and 3 times negative 2. If I do that, I get negative 14 and negative 6, and that gives me my negative 20 that I wanted. And let me draw these lines a little better. Hold on a second. I'm just going to erase all this real quick. I'm going to put that back, and I'm going to put that back. Okay, and in the first one I did 1 times negative 2, 3 times negative 14. And in the second one I'm doing 3 times negative 2 and 1 times negative 14. Recognize the pattern? It's the same as the FOIL pattern. You have to try both combinations before you can eliminate anything. For example, if that hadn't worked, we could have tried 7 and 4, because that makes 28. And we would have done 1 times negative 7, 3 times negative 4, and 1 times negative 4, and 3 times negative 7. And you have to keep trying them until you find the combination that works. Once you find the combination that works, 1 and negative 14 have to be multiplied together. That means they cannot go in the same parentheses. Because things in the same parentheses don't go together, don't get multiplied. So the 1 is over here and the negative 14 is there. And then 3 is here. Sorry, not there. There's that x, 1x. That's 3x, which means the negative 2 has to go there. So I get x minus 2 times 3x minus 14. Do you want to see this one in the same method as that one? And then I'll show you guys the other method. Okay, we'll do the same method as this one. Then I'll show you guys the other method. The first one, which one?
With the parentheses,
Here.
x minus 2.
X minus 2 times 3x minus 14.
Okay, thank you.
Sorry. As soon as I get the tablet, I can pull the screen back down and then we'll blur those away. Alright, so let's, actually, hold on. Okay, so factors of 5 is only 1 and 5. That's my only possibilities, right? Factors of 8, I'm going to try 1 and 8. Okay. So if I do 1 times 1 and 5 times 8, I get 1 plus 40, which is 41, which is not 14. Oh, now I just caught myself. That's positive. I need a negative, right?
Mm-hmm.
So I need to make these negative, which makes this all negative. Okay, so negative 41. Still not right. So then I try 5 times 1 and 1 times negative 8. And I get negative 5 and negative 8, which is negative 13, which is close, but not correct. So 1 and 5 I can't change. The factors of 5 are 1 and 5. There are no other factors of 5, but there are different factors of 8, so now I have to try a different set. So 1 and 5 again, and negative 2 and negative 4. So I come in and I do 1 times negative 2 and 5 times negative 4, and I get negative 2 minus 20, which is negative 22, which is not correct. So then I do 1 times negative 4 and 5 times negative 2, and I get negative 4 and negative 10, which gives me my negative 14, which is what I want. The 1 and the negative 4 had to be multiplied together. That means one, negative 4. Well, if this is 1x, this is 5x, and if this is negative 4, this is negative 10. So to do these exact same problems in the other way, method 2, which revolves around factoring by grouping, the first thing I have to do is take 3 and 28 and then multiply them together. And I didn't memorize my 28s. Did anybody memorize your 28s? No?
Four, 7.
Okay.
I think that's it. 4, 7.
What I'm going to do,
You dropped the X squared.
no, okay, so what I'm doing right now, because on that other method, we had to take the factors of 3 into consideration and the factors of 24 into consideration, or 28, sorry, 28 into consideration. If I multiply them together and make it 84, that includes the factors of 3 and the factors of 28. 84 is both combined, right?
Mhm.
Now what I have to do is find the factors of 84 that are going to give me a negative 20. So I'm eliminating doing all the combinations. So factors of 84, the sum of the negative 20. So I have to think of what multiplies together to make 84. Well, I can do 2 and 42, but that's not going to give me a 20. 12 and 7. Right?
12 and 7. Yeah.
Okay, well, if I do 12 times 7, and they have to both be negative, that's going to give me a negative 19, which is really close, but not quite. They both have to be negative because I'm getting a positive 84, but a negative 20. Okay, so 12 and negative 7, negative 12 and negative 7 isn't going to work, but it's close. It's very close. what about, I was just about to say 14 and 6, because I can take the 2 from the 12 and give it to the 7, and turn that 7 into a 14, and turn this 12 into a 6. And I get negative 6 and negative 14, which does give me the negative 20. Now, when you're doing factoring by grouping, negative 6 and negative 14 equals negative 20, correct? So what I'm going to do is I'm going to take this negative 20 out, and I'm going to put the negative 6 and the negative 14 in, because they have the same value. I'm replacing. So this is going to become 3x squared minus 6x minus 14x plus 28. I didn't change anything. The value is still the same because 6 and 14 is 20. All I did was split the 20 in half. Well, not in half, but in parts. And the reason I put the 6 with the 3x and the 14 with the 28 is because 3 and 6 have something in common. And 14 and 28 have something in common. So if I had written this backwards, where the 14 was in front and the 6 was second, I would have still written the 6 with the 3 and the 14 with the 28. We'll do it in the next one. I'll put it in the wrong order so I can show you what I mean. Now what I do is I look at these as two different zones. The first two and the second two. From the first two, I know they have a 3 in common, so I can take that out. And they have an x in common, so I can take one x out. Now, if I take the 3 away from this, and one of the x's away from that, what do I have left? Just an x. And if I take that negative 6 and I divide it by 3, it's going to be a negative 2, and I took the x away, so it's gone now. Now, if I look at 14 and 28, they have a 14 in common. And when you're factoring by grouping, the idea is for the parenthesis parts to match. I want this to be a negative 2 when I divide it, so I have to divide out the negative 14. If I take negative 14 away from here, I'm left with an x. And if I divide 28 by negative 14, I have a negative 2. These match. Once those match, you're golden. This is one parenthesis. And then these two out front are the other one. There's a little more manipulation here, but not as much trying a bunch of different stuff. So it's what you're more comfortable with. You get the same results either way. Let's try this one. First thing we do is we multiply those two numbers together. 5 and 8. Okay, so we have 40. I'm going to find factors of 40 that add up together to give me a negative 18. 14, sorry, negative 14. 4 and 10. So I want a negative 4 and a negative 10, and that's going to give me a negative 14. So I'm going to take this negative 14x out and put this negative 4 and negative 10 in. Okay, now when I do that, the order I have them in right here is 4, 10, but does 5 and 4, do 5 and 4 have anything in common? No. No, but 5 and 10 do have nothing in common. So I'm gonna put the 10 first, and then the 4, and the 8 stays. So far, okay? And then, like I said, I'm gonna consider it to be kind of 2 separate zones. 5 and 10 have a 5 in common, so I take that out. They have an x in common, so I take that out. And I'm left with 1x, and 10 divided by 5 is negative 2. And over here, I'm going to take out my negative 4. X minus 2, those match. And 5x and negative 4 become the next parenthesis. So 2 different ways to approach the same problem. You're going to have one of these scenarios. A could be a 1, so it could technically not be there, but you're either going to have 2 positives, a negative and a positive, positive and a negative, or 2 negatives. Okay. When you have 2 positives, all your factors are positive. You have in mind that it's a 1. Okay. Everything will be positive. Now, if this is negative and this is positive, your factors are going to be negative. Right? Because 2 negatives multiply to make a positive, but add to make a negative. Okay, so if it's negative and then positive, you have 2 negative factors. If it's positive and then negative, you're going to have 1 positive factor, 1 negative factor, and the positive factor is going to be the bigger number. Because this plus in the middle tells us that that positive factor is going to be bigger than the negative factor. And then if you have 2 negatives, you're going to have 1 positive, 1 negative, but your negative factor is going to be the bigger number. And I'm saying bigger, not greater, because a positive is always greater than a negative, but a negative 10 versus a positive 3, I'm saying 10 is bigger than 3. That makes sense? So positive and positive gives you all positive. Negative and positive gives you all negative, or 2 negatives. Positive and then negative gives you a positive and a negative where the positive is bigger, and then negative gives you a positive and a negative where the negative is bigger. So if you can kind of like keep this pattern in mind, that'll help you make sure you've got your signs correct. It will not always be. Okay, so a quadratic equation can be written ax squared plus bx plus c equals 0, although they won't always be in that format. They can be switched around where you have like ax squared equals bx plus c or something. But you have an ax squared, a bx, and a c, and an equal sign.
What does that word say? I'm sorry. Which word? Where's after it says where?
Highest exponent is a 2.
Oh, yes, thank you.
Yeah, highest exponent is a 2. That's a quadratic equation. Okay. Here's an example of one. Now, the zero product property is the property that allows us to solve quadratic equations using factors. And the zero product property says that if you have any 2 numbers and you multiply them together and it equals 0, then either the first one equals 0 or the second one equals 0. One of them has to be 0, right? You guys agree? I multiply two numbers and it equals 0. One of those numbers had to be 0. Well, using the zero product property, we can use that to solve the equation. So I have x minus 5, that would be A, and x minus 2, that would be B. A times B equals 0. That means this equals 0, or this equals 0. So you split, set them both equal to 0, and then solve it from there. Well, if x minus 5 is equal to 0, I add 5 to both sides, and x equals 5. Or, if x minus 2 is 0, I add 2 to both sides, and x equals 2. You will almost always get two answers on these. The only time you will not get two answers on these is if the factoring matches. So it's like x minus 5 times x minus 5. Then you'd get the same answer for both, and you'd only have one answer. That only happens if it's a perfect square trinomial. The exponent in equations tells you the maximum number of answers you should ever have. So in here we have 2, or 1, or none. If our exponent was a 3, we could have 3, 2, 1, or none. Because there's always a chance that there's no solutions. But 9 times out of 10 you'll have 2. Okay? I don't know if I need 4 steps here. Okay, oh yeah I do. Always make sure it's set equal to 0 first. Okay, so I need to set this equal to 0. So I'm going to take this 35 and I'm going to move it over here. And this is going to become x squared minus 2x minus 35 equals 0. It always has to be set equal to 0 first for us to solve them. Step 2, factor. Okay, we kind of already did this one, except we had a positive 2 last time. And if we had a 7 and a 5, but our 7 was positive and our 5 was negative. So factors of negative 35, that will give me a negative 2 or negative 7 and positive 5, right? Step 3, purple or green? Green. I'm going to split into two equations. X minus 7 equals 0. X plus 5 equals 0. And then step 4 is solve each. Okay, so if this is x minus 7, I'm going to add 7. I'm going to get x equals 7. Subtract 5, and I get x equals negative 5. I put an or in between them because it's one or the other. And there's my answers. Okay, so I need a fact. This one's already set equal to 0, so I don't have to do that. If it's already there, done, you're done. Do you guys want me to make the table to factor this, or the factoring by grouping thing?
This table.
Okay, I have a second and a first. Okay. I have to write kind of small. Factors of 5, factors of 40, and the sum of negative 33. Okay. Factors of 5. negative 33. So these are going to have to be negative factors of 40. Hold on a second. 8, negative 8, and negative 5. Okay. I can try 1 times negative 8 and 5 times negative 5, and I'm going to get a negative 8 and a negative 25, and when I add those together, I get negative 33. Okay. So using this method, get this out of the way so I can use that for a minute. Using this method, I get the 1 and the negative 8 have to go together. So this gives me 5x and negative 5. Using the other method, I do 5 times 40, which gives me 200. And so I'm looking for factors of 200 with a sum of negative 33. Which is going to give me well, 25 to negative 8. Might have had to try a couple more, but they were both there. So 25 times 8 is 200. Now let's make negative 33. So then I replace the 33 with the 25 and the 8. Okay. Factor the 5 out here. Oops, sorry, 5x. Factor out the 5x, and I'm left with x minus 5. Factor out the negative 8, and I'm left with x minus 5. And I still get this part. So x minus 5 times 5x minus 8. So either way, I end up with x minus 5 times 5x minus 8 is equal to 0. Split this into 2 problems. Add 5 to both sides. Add 8 to both sides. And I get 5x equals 8. And when I divide by 5, it doesn't divide evenly, so that's okay. Leave it as a fraction. We are not afraid of fractions as answers. Just leave them as fractions. You don't have to do anything crazy to them. That's a legitimate answer. If you know the tune to Papa the Weasel, you can read this along and sing the song, and it's perfect. X equals a negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? There's a billion YouTube videos of people singing that song, so you can memorize it. Okay? The other one is a story, and it goes like this. A negative boy couldn't decide whether or not to go. To the radical party. Okay, negative boy couldn't decide radical party. But he was square. See, he was square. So he missed out on 4 awesome chicks. So see, negative boy couldn't decide whether or not to go to the radical party, but he was square, so he missed out on 4 awesome chicks. And it was all over. Oops, was all over by 2 a.m. Okay, so you can sing it. How goes the weasel? X equals a negative b plus or minus a square root of b squared minus 4ac all over 2a. Or you can learn the story about this loser kid that didn't go to the party. Or you can say it over and over again, or you can write it over and over again, but you want to know it. You have to know it before you can use it. Now, how does it work? I should know this, but just in case. This is A, this is B, that's C. I replace the A's with 2, the B's with 9, and the C with a negative 5. And then check out the math. You have to do what's underneath the radical first, then take the square root. So this gives me a1 plus 8 times 5, 40. Over 4. And 81 plus 40 is 121. And the square root of 121 is 11. And now I do negative 9 plus 11. And negative 9 minus 11. Negative 9 plus 11 is 2. Negative 9 minus 11 is negative 20. So 2/4 becomes 1/2. And negative 20 divided by 4 is negative 5. Some of you may prefer factoring. Some of you may prefer quadratic formula. First, you have to have the equation. X is a negative boy that couldn't decide whether or not to go to the radical party, but he was square, so he missed out on 4 awesome chicks, and it was all over by 2 a.m. B is 8. So that's A. What am I doing? Catch me when I do stupid stuff, guys. B is 2. A is 8. C is negative 1. 2 squared is 4. Negative 4 times 8 is negative 32. Times negative 1 is positive 32. 2 times 8 is 16. 4 and 32 is 36. Square root of 36 is 6. Negative 2 plus 6 is 4. Negative 2 minus 6 is negative 8. 4 over 16 is 1 over 4. And 8 over 16 is 1 over 2, not 2 over